This piece of news has been a long time coming. In the search for exoplanets, we have seen many planetary atmospheres, but they tended to be around giant planets, more like Neptune than Earth, or enormous gas giants. This is not unexpected. The more gravity you have as a planet, the better you can hold on to an atmosphere. But as Earth very much shows, smaller terrestrial worlds can do it too, and up until now, while we have discovered planets in Earth's size range, none have proven to have detectable atmospheres. A good example here are the TRAPPIST-1 worlds, which is a group of 7 Earth-sized worlds in one system. But so far, using James Webb, characterizing these worlds has shown that at least so far, none of them have maintained an atmosphere. This played into an idea floating around within astrobiology over the last decade or so, that red dwarfs, the most numerous type of star in the universe, spend their early lives very active and flaring, and thus strip their planets of atmospheres very early on. But as they age, they calm down. As a result, red dwarfs over the last decade have slid down the list as far as potentially habitable star systems, and a kind of bias formed. Even though studying planets orbiting red dwarfs is the low-hanging, easiest fruit with which to study exoplanets in general. The bottom line is that they are dim, and thus there is less glare, to put it simply, and that lets you see the planets easier. But there has also been work done in stellar physics that suggests red dwarfs, at least some of them, even if active, actually do not flare from their equators, and the plane their planets orbit in, but rather close to the poles, and may miss red dwarf planetary systems entirely, even though the star is active. What the rules on that are, we don't know. It might be that all red dwarfs are different. But now, the absolute view on that has all been upended, and astronomers have found what is very likely the closest Earth analog planet we have yet seen. It's not an identical twin, but you could call it a sort of cousin level of close. This new exoplanet, designated LHS 1140b, is 48.8 light-years away, and is a rocky terrestrial world like Earth. And not only is it within the habitable zone of its star, it has a detectable atmosphere, and here it comes. It orbits a red dwarf. The red dwarf stars are back on the habitable list, or at least some of them. As an aside, this star is interesting for another reason. So LHS stands for the Luyten Half-Second Catalog, which is a catalog of stars that move more than a half-second of arc from our perspective over the course of a year. In short, this means this star is moving particularly fast in its motion through the galaxy from our perspective. There actually are previous studies done by the James Webb Space Telescope that did hint at an atmosphere, with an unconfirmed report that a potentially nitrogen-rich atmosphere exists at this world. Earth, too, has a nitrogen-rich atmosphere, and the star system happens to be on the upper end for atmospheric studies of its exoplanets for various reasons. But that a red dwarf has a planet with an atmosphere isn't the only unexpected aspect of this planet. So with stars that strip their planets of atmospheric gases, the usual suspects you would not expect to see from an older planet similar in size to Earth would be hydrogen and helium. Helium, even though it's the second most abundant element in the universe, forged in the Big Bang itself and in the cores of stars, is actually really rare on Earth. We have to get it from geology, where it results from radioactive decay, because once it escapes and rises into the atmosphere, eventually the solar wind strips it off Earth and into space it goes. That is just a reality of gravity, light elements, and physics. But the first gas detected in the atmosphere of LHS 1140b is helium. That is just a reality of gravity, light elements, and physics, but the first gas unequivocally detected in the atmosphere of LHS 1140b is helium. Incidentally, being in the habitable zone of its star where liquid surface water on a terrestrial world is possible, I'd say it's a good bet that one of the very first things astronomers will do as study of this exoplanet develops is look for water vapor, if they can, that might indicate whether it's an ocean world. There is already an unconfirmed report from the Hubble Space Telescope here for the detection of water vapor, so that likely will lead to work to confirm that. This is because this planet, having a gaseous atmosphere, should be able to maintain some level of a greenhouse effect, which is needed for liquid water along with pressure. So at this point, it seems like this world probably has liquid water. With liquid water comes the possibility of life, and maybe interesting mixes of gases that might indicate a biosphere. The question is, how old is this planet to still have detectable helium? LHS 1140b itself isn't a new discovery. It was spotted in 2017, and this atmospheric detection is a product of further study by the astronomers that found it in the first place, led by astronomer Jason Dittman. We can call it Earth-like because it's in the habitable zone, has an atmosphere, is rocky, and likely has an iron core. The evidence shows in this case that this planet has maintained an atmosphere for billions of years. It is not a young planet. In fact, the star the planet orbits is about 6 billion years old, older than our solar system. But how is it that a planet with an atmosphere is orbiting a red dwarf? Well, the star LHS 1140b is a red dwarf, about 18% the mass of the Sun and about 21% its radius. And the star itself rotates every 130 days and exhibits no flaring so far. It's very calm, and that is key. There are 2 known planets in this system. LHS 1140c, which is the inner planet, was discovered after B, and is a hot rocky planet. The outer one is LHS 1140b, and that's the one with the atmosphere. They were discovered using the transit method. They pass in front of their star as they orbit from our perspective, so we can see the star dim a tiny amount as they pass across its face. LHS 1140c is about 1.9 times the mass of Earth and has a radius of about 1.3 times bigger. And that means it's denser than Earth, and thus rocky in nature. It has no atmosphere based on observations. With LHS 1140b with the atmosphere, it's a super-Earth, with a year that lasts about 24.7 days, typical for a red dwarf system in the habitable zone. But it was originally estimated to be about 7 times Earth's mass, about 1.4 times its radius. The radius measurements have gone up a bit, to about 1.7 in subsequent years. This is a problem. While that mass might explain the presence of the helium, there is a belief that anything other than microbial life would start having issues with super-Earths above 2 Earth masses. This appears significantly higher. It's still consistent with a rocky composition, however. However, a study in 2023 showed a significantly lower mass of 5.6 times Earth and a lower density, which starts getting out of probably terrestrial worlds and something like a mini Neptune. But more likely, weirdly enough, with the lower density, it could also be an ocean world with 9 to 19% of its mass composed of water. Further JWST observations ruled out a hydrogen atmosphere. That was one thing that could be ruled out, which kills off the idea of a mini Neptune. This world seems to be terrestrial. But there may be different rules in place for a terrestrial world. The question is, what other gases are in that atmosphere? Helium is weird, that wasn't expected, but maybe there is an active geologic process replenishing it, perhaps at a greater rate than Earth does, but Earth does still do it. There is helium in the atmosphere at all times. Also, the red dwarf itself is several billion years older than when red dwarfs start calming down and stop flaring so violently and so much, so it probably stopped atmospheric stripping a few billion years ago. Just to speculate, maybe this particular exoplanet actually started as a planet with a much more substantial atmosphere than it has now, and it retains a remnant. And in fact, Earth also is like this. It once had a very different atmosphere, and that remnant is now a stable atmosphere for this exoplanet. This is interesting because if no atmospheric loss is occurring right now, it very well might be able to retain its atmosphere for trillions of years longer, because once a red dwarf gets out of its active infancy, it then remains stable for trillions of years because those stars are fully convective. They convect their gas and actually have more usable fuel than a larger star because they can use most of the fuel they were born with, whereas larger stars cannot, as they can't convect fuel from the outer layers of those stars down to the core. There are also other interesting aspects about this system in general. There may actually be more planets there, with a possibility of a Neptune-massed planet further out in the system than the 2 known exoplanets, but that's currently in question as stellar activity, even though the star seems calm, can throw off radial velocity signals, and in this case, apparently no transiting is seen. Radial velocity detections of exoplanets is done by measuring a star wobbling from the gravitational tug of its planets. but it's easier to fool through stellar activity than transiting and dimming tends to be. If I had to guess, this world might be a candidate for looking for the biosignature gases of microbial life, but not a true second Earth. But it is a planet that has certain relations with Earth, and will at least give us a way to characterize what planets can do to hold on to helium, but not hydrogen, which may lead to constraining masses that can do that with light elements, and will at the very least learn significantly more about red dwarf planetary systems as far as terrestrial worlds, and where the exact line is as to how big they need to be to hold on to atmospheres during the young period of their star's life. And who knows, maybe with further work, something weird may surface. But at least we now know that red dwarf stars can indeed have rocky terrestrial worlds that can hold on to their atmospheres. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently glad I do not live on a planet larger than Earth with higher gravity. That seems like a lot of work for a human. The bodybuilders might like it. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.